Today we are going to do FRQ topic number 7. This is motion along a curve, or parametrics and vectors. Most of these are with a calculator. You can see the recent years that we've seen them, so we've seen them quite a bit in recent years. This topic is very formula heavy. There is no way around it. You need to know your formulas. Position is you can write it as a point or a vector. There's an x coordinate and a y coordinate, and t is the independent variable. Think of it as time. Velocity must be a vector. X prime, y prime. Acceleration vector, x double prime, y double prime, always a vector. Speed is the magnitude of the velocity vector. It's the length of the velocity vector. It is always positive. This is our formula for speed, and you must know it. No integral, just the square root. X prime of t indicates horizontal movement. Left if it is negative, right if it is positive. Y prime of t indicates vertical movement. If it is negative, we're going downward. If it is positive, we're going upward. Magnitude of displacement. Magnitude of displacement is the distance, just the distance, between the origin and a point on the curve. So it is just our distance formula. Okay. Total distance traveled is our integral. It is the integral of speed. Integral of speed. That's how I remember it. In fact, I will put that on here. Integral of speed. Okay. The things that I have with three stars here, those are the ones that I always see. Slope of the tangent line. dy dx, dy dt over dx dt, which is the same as y prime of t over x prime of t. Every once in a while you'll be asked to find the second derivative, which means you're taking the derivative with respect to x of the first derivative with respect to x. The difference is the derivative with respect to x is going to have t's in it because our independent variable is time. So you're taking the derivative with respect to x of something with t's in it, so you use implicit differentiation. First you take the derivative with respect to t, then you multiply by dt dx because of the dx down here. dt dx is 1 over dx dt. Alrighty, we're going to do the FRQ from 2023. This was number 2. This was with a calculator, so I'm going to grab my calculator. I'm going to clear out what's there and get ready here. Alrighty. Between 0 and pi, a particle moves along the curve shown, so that its position at time t is x, y. So this is x and y. There's another variable t in play that for time. It is known that dx dt is e to the cosine of t. That is going to go in for my y1. And then it says at time 0, the particle is at the position 1, 0. So this right here is our starting position. Okay, I'm going to put dx dt, x prime of t, in for my y1. Alrighty. Oh, I didn't finish reading this. X of t is not explicitly given, but y of t is explicitly given. They give us y of t here. Y of t, I'm going to need y prime of t. Remember, for these in your calculator, you always want to put x prime into y1 and y prime in for y2. So I'm going to find y prime and put it in for y2. And this is something that I would do by hand. I would not use my calculator to find that derivative, but I do need to say what I'm doing. So I'm going to come down to my workspace and say y prime of t is 2 cosine t. And I'm going to now put that into my y2. Okay? Alrighty. They also give us this at time 0, the particle is at 1, 0. So I might put that down here before I get going on the question. Usually we need that. X at 0 is 1. Y at 0, remember that's time. Y at time 0 is 0. Okay, now we're ready to begin. Part A. Find the acceleration vector. Acceleration vector at time 1. So acceleration vector at time 1, I need to say what I'm doing. It is x double prime at time 1, y double prime at time 1. And then I'm going to use my calculator to do that. So I need the derivative of x prime at 1 and the derivative of y prime at 1. Math 8 with respect to x of y1 at time 1, and then the same thing for y2. So this is the x coordinate of the acceleration vector and the y coordinate of the acceleration vector. Okay, so feeling good about that one. Let's go on to part B. Part B, for time between 0 and pi, find the first time t at which the speed is 1.5. Show the work that leads to your answer. So here's speed. Speed is our square root of x prime of t squared plus y prime of t squared. Okay, we want to know when is that 1.5. So I'm going to go to my calculator, I'm going to go to my y equals, I'm going to put speed in for y3. If you recall, when we did this unit, I always encourage you to put speed in for y3. So that's the square of y1 plus the square of y2 underneath that square root. And we want to know when is that 1.5. I know I'm going to be finding an intersection. This pink to me is too light, so I like to go down to a darker color. That green seems to work well for me. So I'm going to put 1.5 there. I don't want to see my y1. I don't want to see my y2, so I hit enter on those equal signs. Lastly, before I graph, I'm going to go to my window. I need to restrict it between 0 and pi. And I just need to make sure that my y's include 1.5. They do, so I'm just going to graph that. There's the speed. And there's 1.5. They asked me for the first time that they match. So find that intersection. Second, calc 5 for intersect. Enter, enter, enter. It always jumps to the closest intersection point. So that is at time 1.2544. At least 3 digits after the decimal point. On to part C. Find the slope of the line tangent to the path of the particle at time 1, and then we're going to come back and finish because then we have to do something else. But first let's find the slope of the line tangent at time 1. Slope at time 1. So that is dy dt over dx dt at time 1. Oops, there you go. Okay, so y prime of t at time 1, one way to do this, here's y prime. So one way to do this is just to put 1 in for t over dx dt at time 1. dx dt was what they gave us, e to the cosine of 1. That would be a safe stop spot. Okay, if you really want to, you can put that into your calculator. If I really wanted to do this in my calculator, I could do y2 at time 1 divided by y1 at time 1. And that gives me the value of this. Okay, we can confirm that if you wanted to. 2 cosine of 1 divided by e to the cosine of 1. Same thing. Okay, but I'm just going to leave it like this because I can. Okay, now let's continue. Find the x-coordinate of the position at time 1. Find the x-coordinate of the position at time 1. We know the x-coordinate at time 0. We want to find it at time 1. So I set up the fundamental theorem. X at time 1 minus x at time 0 is the integral 0 to 1 of x prime. We know x at time 0 is 1, so move that to the other side. And I'm going to let my calculator do the rest. Okay, 1 plus math 9, 0 to 1, and x prime is stored into my y1. And that is the x-coordinate at time 1. On to part D, find the total distance traveled. We have a formula for that. Total distance traveled between 0 and pi. So for part D, integral 0 to pi of speed. We always have to say what we're doing. So this is what we're doing. We have to write that down. And then we can let our calculator do the rest. Math 9, 0 to pi. And we stored the speed in for y3, so I can just put y3 in. 6.034. Or 6.035. Okay, and that was that problem. Let's see how it was scored. In part A, they gave 1 point for x double prime of 1 with setup, and 1 point for y double prime at 1 with setup. Meaning, you had to say how you got that number. Okay? Part B. This was also worth 2 points. 1 point was for the speed equation. The speed equation, they wrote it out on their ideal solutions. They wrote it out like this, but what we did was perfectly fine. However, you cannot use y prime notation if you don't say what y prime is. Okay? So 1 point for setting up that equation, and then 1 point for your answer. Okay? Essentially exactly what I wrote down. Okay, part C. 1 point was for the slope with supporting work. 1 point was for the integral And again, they wrote it out. I just left it as an x prime. And then 1 point for your answer. Part D was worth 2 points, 1 point for the integral, and 1 point for the answer. These are usually very high scoring points this year. Our average was 6.6. Look how far above the global average that was. That was a lot. That was a big difference. Almost 2 points higher than the Texas average. We tend to do good on this. I think it's because my kids can memorize. They know to memorize, and so they memorize. So that's very high. That tells me that there were a lot of tests that had all 9 points earned on this one. So a very strong FRQ topic for us.